Good day. Welcome to this lecture series in Godot.
Hello, good day. Welcome back. In this video, we will work on the parent-child relationship between nodes. So let's get started. So we have these nodes here. So what I'll do, the first thing I'll do, I'll go back to here and I'll reset the scale. I'll save. This will reset back to 1. So I'll go back here. So the both nodes are here. And you know what? I will take off these editable children. Okay, so we can no longer edit the children of this instance of a node, instance of a scene. And what I'll do, I'll reset both instance of the scene to here. So what I'll do, I'll go to the transform, select player, and to look for the transform, reset, and select player 2, and to look for the transform, and set reset here. So we have both instances of the scene at the same point. So I'll call this one player 1 the parent. I'll call this parent. So I just double click and so to open up with this right there and type in or selecting rename. So parent player 1. And to rename this, I'll right click and look for rename. That's how to rename. Call this child player 2. So I want to make this a child of this one here. So this must be a child of the parent. Right now it's not a child. Right now they are combined as siblings. You know what I'll do? I'll take this, select this with left click, drag this. I can leave it like this, and just put this into the parent here, player 1, and the child is now literally a child of player 1. And if we select the player 1, we can minimize this. And if you select the player 1, that's okay, so that's the player 2. If you select the player 1, when you move the player 1, the parent will also move the child as well. But if I select the child, I can move the child separately. So I'll just reset this, reset the child. You see, reset the child, and the child now goes to its default location, and its default location is here, right here with the player 1. But the player 1 has been moved to here. So if you select the player 1 and move, no, yeah, okay, so press undo and let's select the move tool. So select the player 1 and move. You see all the tools are useful here. So you select the move tool, you move player 1 and player 2. If you want to reset both of them right here. Go back to the select tool. You see all the tools are very useful. So one thing you should know about the parent-child relationship. If I have a parent node and below the parent node are children, if you delete the parent node, you will also delete the children. Then we select the parent node here and press delete on the keyboard. It asks you to delete. Yes, we delete. We see we no longer have the parent or the child node here. If we want to bring them back, we press Ctrl Z. So changes that made to the parent node will affect the children as well. And the next thing we want to, we can observe is that the children properties will be relative to the parent properties. And this was seen here when we move the location. So we have this parent here and we have the child here. We can move the child anyway, but anytime we select the parent, and let's choose the move tool here, and we move, we see this child was about this distance away from the parent. So if we move the parent, we will also move the child. The child will always stay a certain distance away from the parent because the child will always have a property in relation to the parent. Whatever is this child here, because we move this child this distance away from the parent, it will always be this distance away from the parent, regardless of where we move the parent to. As we are here, I can also introduce you to the coordinate system in Godot. So if you look at here, right, this is the x-axis, this, what I say, horizontal line is the x-axis here. This vertical line, this green vertical line is the y-axis. And where they intersect will be at this point here, 0, 0. We see at the transform position, 0, 0. Now, if we go, let's say 100 pixels to the right, this will go across here. So let's press enter. You see this point across there. So if we put 100 pixels to the bottom, well, it will go down. Now, this is very similar to like maths class when you're working with, like, let's say coordinates and gradients. The only issue is that when the y-axis, when we go down like this from the origin, when you go down, it will usually mean that the y value will take a negative value. But in Godot, when you go down, we just use a positive value, and if you use a negative value, it will go up. So let's put minus 100. So go up, we press minus 100. You see it has gone up when you press minus 100. And for the x, it will work the same way. So if you put the x at minus 100, it will go back somewhere here. You put minus 100, enter. It has gone backwards here. The parent has gone backwards. And if you select the child and reset relative, it will go right here. So this is just a brief introduction to the coordinate system in Godot. So I want to mention this whole system whereby we are changing and remove the parent and the child will also move. That same system also applies to all the nodes. So let's move this here. So let's go to parent and let's move this here, move this here. So let's click this one, level 1, in node 2D, which is the, how can I say, the parent. All these nodes below here are children of this node here. So let's move this. And when we click move, everything moves, including, well, also the texture rect, which is the background. So everything also moves. So that's because everything below here, all these nodes below here are children of this level 1 scene here. So let's just go back to the transform and let's reset this. So that's very good. So that whole issue when we went to the transform, well, this is the position property. When we change a property in the parent, it will also affect the child. That works for all properties. So like let's say remove a child. Remove the child. Let's carry it up a bit. You see, we carry it up a bit. It's minus 62. But let's adjust the scale. So let's put the parent and let's adjust the scale. So right now the scale is 1. Let's adjust the scale and put the scale at 2. You see, when change the scale to 2, the parent change and the child change. So the parent scale is 2, but the child scale is 1. The child scale is still relative to the parent. So that whole relationship, our child value is set in relation to the parent, that applies throughout for all properties. So I just wanted to elaborate on that. So I have a challenge for you to demonstrate or test your understanding. So create a 5-level parent-child relationship. So if you have one parent and we have a child, that's a 2-level relationship. If this child has a child of its own, we'll have 1, 2, 3. It will be a 3-level relationship. So I want you to create a 5-level relationship. And you can try to, let's say, change some properties of the children and see how it works. So that's a challenge. And to you, you can go ahead and do it. So if you have implemented this challenge, what you can do, well, I'll just select this tool here, select tool. I'll just duplicate this, 1, 2, so 5, and I'll make this a child of this. I'll make this a child of this. I'll make this a child. So we have a parent, child, grandchild, great-grandchild, great-great-grandchild. Okay, so we have all the children, and I now realize that the children, so you have child, you have the grandchild, select this. So player 1, player 2, player 3, but we didn't move player 4 and player 5 are still in relation to the player 3. So you can select this and you can move this. And then we can select player 5. I can move this. And let's change our property. So let's select the player 5 and let's go to the transform. Let's put the scale at, let's say, 5. Okay, so let's set up it too big, so let's put at maybe 2.5. And let's go to player 3 and let's make player 3 also 2. So go to transform and make this, let's say, 2. And we see player 3 here, the child, we change this to 2. When we change this to 2, this gets bigger, but player 4 has changed in relation to this, and this has also changed in relation to this. So because this player 5 is inheriting properties from player 4, and player 4 is inheriting properties from player 3. So player 5 is set at level 2. It is 2.5 the size of player 4. Player 4 is 1 times the size, so it's equal in size. 1 is equal in size to player 3, and player 3 is 2 times the size of player 2. So what will happen is this will now be 2.5 times the size of player 3. So you can see how a node changes in relative to the value. A child changes its parameters relative to the value of its parent. So I just went and I moved to select move tool here. I just went and I changed the scale accordingly. So we saw how we change the properties, and we saw when change the position and the scale, how if we make a change to the parent, how it affects the children. So let's make another change here. So let's say we have level 2. We have this child here, player 3. Player 3 is a child of player 2. So what will happen? Let's make this invisible. So we'll toggle the invisibility. So this is child. This is player 3. When we make this invisible, we also make player 4 invisible. We also make player 5 invisible because their values is set, are set in relation to this one here. This is the parent. But observe, we can still see player 1, we can still see player 2 because we didn't toggle their visibility, and they are the parents. So they are the parents. So what happens in the child does affect the parent. What happens in the parent affects the child. So this works across the board for just about every property. So the last thing I will do before I close this exercise, we have these nodes here, children here, and we can select this player 2, and we can select this node here, and I'll press delete player 2, and because we delete player 2, we delete all the children of player 2, all the children, all the grandchildren, and so forth. So because we affected the parent, we also affected the children. So that is basically what I wanted to explain in this video, the relationship between parent and children. So I achieved the objectives for this video, so I'll end this lecture here. Thank you.